Alright guys, welcome to this page of the notes, and what we're going to do now is we're going to take a look at when a transversal, right, intersects parallel lines. These theorems and postulates only apply, well, postulate and two theorems, only apply when the transversal is intersecting parallel lines. If they're not parallel lines, these do not apply. All right, that's why parallel lines is highlighted. That is the most important thing. It's only if the lines are parallel. So the only time that this stuff works is if I have two lines that are parallel lines, and they're cut by a transversal, right? So that is the only time that this postulate and these two theorems apply. The only way you can use them is if you are told you have two parallel lines and they're cut by a transversal. Let's quickly take a look at them, and then we'll use them here in an example problem. First, same side interior angle postulate. Well, we recognize that same side, that means corresponding interior angles. Here's what it says. Two parallel lines are cut by a transversal, then the pairs of same side interior angles, supplementary. Again, here's what that means. Remember, supplementary means sum to 180 degrees. Well, that could be very useful, and we'll see how that'll be useful when we get down to an example problem and we start solving some stuff. So as long as the lines are parallel, if they're cut by a transversal, same side interior angles sum to 180. So that could be those ones, it could be those ones. In fact, let me number them here. I have 1, 2, 3, 4, 5, 6, 7, 8. So that means that 3 and 5, if these lines are parallel, 3 and 5 sum to 180 degrees. 4 and 6 will sum to 180 degrees. That's what that postulate says. The next one, if two parallel lines are cut by a transversal, that's what I've got, then the pair of alternate interior angles have the same measure. Same measure means that they are congruent. So here's what that means. Alternate interior angles are congruent. So if I have two parallel lines cut by a transversal, alternate opposite sides of the transversal interior angles, alternate interior angles, 3 and 6, same measure, they're congruent based on this theorem. 5 and 4, alternate interior angles, they're congruent based on this theorem, right? As long as those two lines are parallel, alternate interior angles are congruent. And then my last one, corresponding angle theorem. This is a really good one. Two parallel lines cut by a transversal. So they have to be parallel lines cut by a transversal. Then pairs of corresponding angles. Remember, corresponding angles are angles that are in the same position in different intersections, right? Here's what it says. Corresponding angles have the same measure. So once again, corresponding angles are congruent. Corresponding angles are congruent. So let's take a look at this. Corresponding angles. Well, two intersections, angle 1 and angle 5. Corresponding angles, they must be congruent. 2 and 6. Corresponding angles, they're in the same position, right? Top right-hand corner, different intersections corresponding, so they must be congruent. 3 and 7, congruent. 4 and 8. Corresponding angles, they must be congruent as long as those lines are parallel. So let's go ahead and apply this now in an example problem. Here we go. I tell you in the diagram M and N are parallel. You got to be able to read geometry. So I'm telling you that these two lines are parallel. Let me go ahead and put that into my diagram. Whoop, I don't want to cross it out. I want to box it. Put that sucker in a box, and on here I'm just going to put my little arrows on there so I don't forget. I told you these two lines are parallel, so I'll put my little double arrowhead on there, or single arrowhead on both of them to let me know those guys are parallel. Now, I tell you that the measure of angle 6 is 61 degrees. I want you to find the rest of the angles. Find the rest of the angles. Well, here we go. Angle 6, this guy right here, boom, right there is 61 degrees. All right, let's just jump right into this. These are parallel lines. So we're going to run through it using what we know about angle relationships, a transversal. That's why I called it line T. So original, I know. My transversal is cutting two parallel lines. So here we go. Okay, well, first of all, let's just use alternate interior angles. Alternate interior angles means that angle 6 is congruent to angle 3. Yeah, that's what the alternate interior angle theorem says. Alternate interior angles. Alternate 6, 3, those are interior angles. They're on opposite sides of the transversal. They have to be congruent. So that means that the measure of angle 3 is also 61 degrees. All right, there's one. Now, we're going to use not corresponding. What's the word I'm looking for? Hang on, it'll come to me. It is... I forget the word. Consecutive. Holy cow, talk about a brain fart. Geez. Consecutive interior angles. Okay. I have two pairs of consecutive interior angles. 3 and 5 are consecutive interior angles. They're interior angles on the same side of the transversal. 4 and 6, consecutive interior angles. They're on the same side of the transversal. So here we go. I'm going to do angle 6 and angle 4. So angle 6 plus angle 4 have to sum to 180 degrees, right? That's what consecutive interior angles tells me. Same side, interior angles, right? This postulate right here. That one. Same side interior angles. They have to sum to 180 degrees, right? So there it is. Same side interior angles, right? Consecutive interior angles, 4 and 6, have to sum to 180 degrees. Well, I already know what 6 is. 6 is 61 degrees plus angle 4 equal to 180. So I'm simply going to subtract 61 degrees from the other side, right? If I do that, did I do that? I did, 119. Now, you've got a couple options. You could again do consecutive interior angles for 3 and 5, right? You know the measure of angle 3 at 61 degrees. You could do consecutive interior angles for 3 and 5 the exact same way and get the measure of angle 5. Or you could recognize 4 and 5 are alternate interior angles. Alternate interior angles have the same measure. Either way, whichever way you decide to do it, you'll find that the measure of angle 5 is also 119 degrees. So what we know is that alternate interior angle 4 is congruent to angle 5. And since angle 4 is 119 degrees, that's equal to the measure of angle 5. All right, we're doing really good. I was given the measure of angle 6. I just found angle 3, angle 4, and angle 5. So that's 6, 3, 4, and 5 are all done. Now I need to get my exterior angles. All right, here we go. Let me slide this over a little bit. Going to start off linear pair theorem. So my linear pair, What is my linear pair? Well, I've got a bunch of linear pairs. I'll just do this one, right? Angle 1 and angle 3, right? Those guys form a linear pair, straight lines. So angle 1 plus angle 3 have to sum to 180 degrees. I could do that. I could also do corresponding angles. I've got corresponding angles, right? What if I did this? Angle 5 is in the top left-hand corner of this intersection. Angle 1 is in the top left-hand corner of a different intersection. According to the corresponding angles theorem, angle 1 and angle 5 have to be the same. Angle 1 is congruent to angle 5, which means angle 1 equals 119 degrees. Either way, whether you do the linear pair theorem, again you'd get 119 degrees, or do corresponding angles, you're still going to get 119 degrees either way. Now, interesting, here we go, check this one out, because it's worth mentioning or coming back to. What if I did vertical angles? We talked about vertical angles in the last section. Check this out, I have vertical angles right here, 3 and 2. Those are vertical angles, angle 3 and angle 2. Well, I know vertical angles mean that they have to be congruent, so angle 3 congruent to angle 2. And I know what angle 3 is. Angle 3 was 61 degrees. So slide up a little bit and I get 61 degrees is angle 2, and there is another one, right? So I could do vertical angles. Here's what else I could have done. I could have done 2 and 4 as a linear pair, right? Or I could have done 2 and 6 as corresponding. I happen to do vertical angles. Do you see that? 3 different ways to get the exact same answer. I could have done a linear pair, 2 and 4. I could have done corresponding angles, 2 and 6. I did vertical angles, 2 and 3. Either way, I'm going to get 61 degrees. Doesn't matter which way I do it. Angle 2 comes out to be 61 degrees. Now, alternate exterior angles, 2 and 7, so they have to have the same measure. That means that angle 7, 61 degrees. Alternate exterior angles, and that means that the measure of angle 8 is alternate exterior from angle 1, so it has to be 119 degrees, right? So again, I know that there's a lot of different angle relationships. You have corresponding angles, angles in the same position in different intersections. You have consecutive interior angles that sum to 180. You have vertical angles. You have alternate interior, alternate exterior, right? There's a lot of different ways to do this. It just takes practice. So what we'll do is on the next page of the notes, we'll take a look at a couple more example problems where again, we can sort of rehearse all of the vocabulary that we're using, as well as see how it works out in a diagram by actually doing an example problem. So head on over to the next page of the notes. I'll meet you guys there.